Hello. Hey, this is stream number 70. It's actually the second stream for today. My last stream, I was trying to finish up AWS API signing, but I ran out of time, mostly because I got stuck on stupid bugs. Stupid because I should have caught these bugs long ago, because they're in libraries that I worked on stream months ago. I just never ran into these particular test cases, so I think I've gotten through them. Now we're down to just 4 test case failures, and this is on the most difficult step in the AWS API signing process. And let me just briefly talk about overall. So I always like to start on a plan page. I have all my plans in OneNote, and there's a link below on my stream page to the front of my notebook. And I'm trying to make a link to the page I'm streaming about each day. And AWS API signing has some pretty good, I have to admit, documentation online. They break down signing AWS requests into 4 tasks. I'm not really covering task 4 because that's attaching a signature to the request, and really all I care about in the library I'm working on today is making the signature, so tasks 1, 2, and 3. So I've broken it up into 3 tests to match the 3 tasks. And so what is AWS and what is an API signing and what is all that? I kind of covered that a few streams ago. I've been building up a web service architecture. Hold on a sec. Web service architecture. So I basically made my own web server, web client, web sockets, and all that sort of things. And I kind of want to integrate and run on Amazon Web Services, which is a cloud computing platform. They use RESTful APIs, in other words, web calls, that are sort of in the spirit of how HTTP protocol was designed way back when. The problem is they want all API requests, HTTP requests, to be signed using a key. And the signing process is a little bit involved. So usually they provide an SDK, software development kit, to help you to do that part, but they don't give a C++ version. And since in my stream I like to reinvent the wheel, show how to write things from scratch in C++, I figured, hey, this is a great opportunity. Write my own wrapper for the signing of API requests for AWS, right? So that involves, at the very core of it, using a hash function, SHA-256, and HMAX, which I always forget what it stands for. It's hash-based message authentication codes. So those 2 technologies are used, and we went over that 3 streams ago. So if you're interested in that, look for stream 67. Now, to get the stuff to sign, we go through this process of generating, let's see, how do I show this? Right, making the authorization code is using the hash function, but what do you sign? You sign a special string that you form from what they call a canonical form of the request. And that's what we've been working on, this first step of constructing the canonical, what Amazon calls canonical form of an HTTP request. So for example, this is not a good example here. Where's a good one? How about just get vanilla? So here is an incoming HTTP 1.1 request, and here's the canonical form. So they basically have the method on its own line, the URL on its, or URI on its own line, and then I believe the 3rd line is reserved for queries. So like if you have one with a query in it. No, that's not a query. Where's one with a query? How come that's empty? That's bad. They shouldn't have an empty one. They should actually have one with a real query in it. Like that. So that's the one with the real query. You can see that 3rd line has the query form, which the query part of the URI there. And then all the headers in a certain form where you get rid of spaces and you convert to lowercase, then a blank line, and then a semicolon delimited list of the headers, and then the message digest of the body of the message. And that happens to be the digest of empty string, because this request has no body. And for example, one with the body like this, that's the body. It has a different digest here. So last couple streams I've been working on a component that will basically convert between that and that, right? They're pretty similar. It's just we have to do a bunch of converting to lowercase, breaking up the URI, all sorts of things. And there have been a lot of corner cases to deal with. So I'm down to basically just a couple things. There's one rule where we have to collapse extra spaces in header values. There's a question on how to properly handle folded header lines. So that looks like this multi-line thing, where you have a space as the first character of a header line. So in HTTP 1.1, they call that an obsolete folding. And I'm going to argue that the official spec for HTTP 1.1 says you must not generate such a message. If the server receives such a thing, it must either reject it, or you could replace the obsolete folding with one or more space octets. So given that, I believe that their test is not valid, because what they do is they expect, see, value 1 should be space value 2 space value 3. They actually have it as commas. I think is not valid. So actually, I've decided to throw out this test case entirely, because we really have no business. We have no business making a request with the obsolete fold rule, because the spec says we must not generate such a message. So if their code incorrectly or improperly replaces obs fold with comma rather than a space, it doesn't really matter, because we'll just avoid the problem entirely by never matching obs fold in our requests, because we shouldn't. The spec says we must not. So I'm just going to completely throw out that test case. And then the couple of the other test cases that I want to modify are the ones with bodies, because I think I went over this in the last stream, or the one before that actually, in my notes, that the RFC, again, for HTTP 1.1 says that if you have a message body, you have to signal it with either a content length or a transfer encoding header. And if you look, did they put a content length or a transfer encoding header? No. Bad Amazon. So this is the body, but there's no content length, no transfer encoding to signal it. So I'm going to kind of fix their tests by including the content length header, but that's going to change these message digests. So I'll have to change the test vector's message digest to match. So I'll just do that last, because I need to actually be generating the codes and stuff to update the test vectors to have. So anyway, let's get started. So when I run the test right now, you'll see the things that are failing. So here's the one I was talking about before, where this is the test case I want to throw out, because I think it should be spaces, but they're putting commas, and I'm like, well, it's obsolete folding anyway. We should never have to deal with such a request. This one we need to handle. They want a sequence of 2 or more spaces in a header value to be replaced by a single space. All right. I don't know why, but whatever. And then these last 2, we're going to fix those test cases after the end when we're done. All right. So let's just throw out this test case. This test case is called get header name rec, get header value multi-line rec. So we can simply go to our tests, and when we're actually making the test vectors, right, finding the test vectors, we can just simply throw out that line right here. We can say if entry name is not equal to that. Actually, that's without the rec, right? What we'll do is we'll say if it is that. Well, let's throw it out early. As soon as we get the entry name, if it's that, then we're going to continue. And let's put a note here. Throw out this. Actually, you know, is it better to do a comparison here, or just delete it? I think we'll just delete it, because it's not really a valid test case. So deleting is fun, right? We get to go in here and just say delete. Bye-bye. Build. Actually, we shouldn't have to really build, right? We just run again, and that test case doesn't exist anymore, so we won't see it. So now we just have the 2 tests with bodies that we have to fix. And then we have the spaces thing. So let's do the spaces thing, and then we'll move on. We'll be able to move on to making the string design, making the authorization code. Then we can go back and fix those last two test vectors that have bodies in them. All right, so spaces. In the actual place where we're dealing with its header values, right? So that was step 4 here. And we have the values here. Here we have the value, and here I have a to do, right? I should have seen that right away. I had marked where we want to do it. So what we'll do is we'll just make a function. Remove, or we'll say canonicalize, because you know that's such an awesome word. It should be a word. If it isn't, then I hereby make canonicalize a word. Canonicalize. Let's be more specific. We're canonicalizing the spaces. All right. So we're going to have a helper function called canonicalize spaces. Helper function, it's a local function, so it's an anonymous namespace. And let's document this before we write it. So we're going to say, this function replaces sequences of 2 or more spaces with a single space. To meet the requirement of header values in canonical API requests, that multiple spaces should be replaced by a single space. Maybe that's a little bit redundant. This is the string for which to replace multiple spaces with a single space. I have a feeling I'm going to be mentioning that a lot here. It's going to be like 3 times I say it. The given string with multiple spaces replaced by a single space is returned. I'm not really feeling like a perfectionist right now. Otherwise, I'd work on that English a little bit. I'm just going to do something simple here. So it will be, I already have SStream. So OString stream is one of my favorite construction, or what do you call it? Builder objects. So we're going to build a string character by character, and we'll return when we're done. So it's pretty simple. We'll just say const auto char in the string. And let's have a flag. Last char was space. And we'll set it to false. And we'll say if C is space, else. And then if it is a space, if the last character is a space also, then I think we just do nothing. We ignore that. Otherwise, so basically reverse this logic. We will set last char space to true. And we want to output at least one space. So output a space, right? If it wasn't a space, then output it. And then we'll say, okay, for the next time, last character space was false. I think that's all we need to do. So we can now try this and see if our test case works. So I'm using test-driven development if this is your first time here. I built up the test first. So it's a combination of these helpers and actual test cases. And I'm using the Google test framework, which lets you specify each test that make it look like a function, and you can have common setup if you want. That's called a fixture. And you basically have asserts and expects to do the testing. If they don't meet what you assert or expect, then the test is marked as a failure. Otherwise, it's a pass. Okay, then. Let's run that guy. Cool. So we're just down to those 2 test cases with bodies that we can simply fix up. So let's move on. That means this canonical request is done. Even though it's failing because these test vectors are bad. We'll move on and we'll come back to those, all right? So make string design. Let's review what's needed for that. create the string to sign. Okay, so they want the algorithm name, the request date and time, credential scope, hashed canonical request. Okay, so that we'll need the canonical request. We'll need to hash it. We'll need 3 other, well, let's hard code the algorithm, you know. So we really only need 2 more arguments to, we're going to make a function, right? It's going to take 3 arguments, the request date and time, credential scope, and we'll just put in the canonical request, and inside we'll select the hash algorithm, print it out here, and then use it to hash the canonical request. Sound good? Sounds good to me. So let's reuse our test vectors. And actually, I'm going to take this whole body here. Only, we will start with the canonical request. So instead of test vector, so we're going to remove this stuff here. So we'll start with the canonical request. We'll open and read it in, and then we're going to also use the string to sign is what our output should be. So basically, given this canonical request, we should have this string to sign. This will be the input to the test, and this will be the output. Let me pin those. Pin them up here. All right. So it's STS, right? And we'll call it the string to sign file. And then we'll have the string to sign contents. And then we'll expect the string to sign contents. We'll expect that to equal make string to sign. And okay, we don't need to do this cleanup request anymore, right? Because we're going from the canonical request already. So we'll just pass in the canonical request. And I'm converting vector, or basically this is a vector, not that thing, this thing. It says file buffer, but file buffer is a type def to vector of bytes, basically. So we need to convert it to a string by using this string constructor that takes an iterator for a range. Only instead of STS here, it'll be C rack contents. So that's the canonical request. And actually, let's put it in the same order that Amazon lists it. So we need the request date and time, which we need to figure out, and then the credential scope. So let's figure those things out. I'm waiting for the red squigglies. It should put red squiggly here, but I think the whole thing is indicated as bad because it's a macro. So to fix the macro, I think we need to fix all 3 things. So we'll need to make a method called make string to sign. Let's just define it for now. Static. And it has 3 things, right? The request date, time, credential scope. Let's make that 2 words there. And then the canonical request. Canonical request. I actually don't know if these are the arguments and types that we'll use yet, so I'm waiting for the squigglies to go away here. Come on, there we go. I just want to define it. And then let's define, we don't know what these are yet, so let's just define them. Okay. So let's work backwards from a test that runs but fails. Okay, and this doesn't. So it doesn't because I don't have a definition for this. So we'll put that in its proper place, right down here. If I could type right. Okay, so get rid of the static. Whoa. Keyboard fail. Right? Is that right? I can collapse this. We can kind of see that it goes, okay, yeah, I'm missing the class name. And then we need to return something, or else it won't compile. Okay, so it builds, and we can run that test, and we can just focus in with gtest filter to sign. So yeah, we're getting a bunch of... That's interesting, they're all zeros. So I think our test isn't right. It's not reading the string to sign properly. Oh, dot is, should it be dot? No, that's right, STS. Open. Get the size. Oh, it never did the read. Oh, no, it did do the read. Oh, but this is wrong. There we go. This is why you should do things step by step. I want to actually see that the expect strings are correct. And it's not matching the actual return, because the actual return is always just empty string. So yeah, the way you read this is it's saying where a test failed, and then it shows you what the expected value was. Hold on, I gotta mute the mic because my dog is barking. The dog's barking because someone came home. So yeah, again, the way you read this, it always tells you the source line in the test where the test failed, and it shows you what the expected value was in the code, and it says what it actually is at runtime. And then it shows you what the expected value, or what the actual value was, and what that is at runtime, which is this empty string. And then if it's a string, it shows you a nice diff. It's basically saying all the lines that are expected are missing, or replaced with empty string, right? So yeah, so the test is correct. So well, the test is correct, except for I don't think we need to actually pass in what the expected request date time and credential scope are. How are we going to get that? This might be a little tricky. So let's look at a signed request. It's right here. I'm hoping that every single one of these test vectors gives it in the form of AMZ date, because that would be convenient. The other way you could get the date is from a traditional DATE header, and that would make our test a little bit more difficult, because we'd have to check if they're always x-amz-date. We can just search for that, and then take all the characters to the end of that line, and then capture that as the date and time string. I'm gonna hope that that's true, because then this string always will match this string, right? Yes. Okay, so that's what we're gonna do. And do we want our users to have to construct the date and time in this format? I don't think it's that onerous. Yeah, so we'll require that. Makes it easy on everybody, right? Or wait a minute, hold on. Our user really shouldn't care. Yeah. I'm thinking what we'll do is we'll check to see if their canonical request they're feeding in actually has this. If they don't, then we'll search for a date. And if that's not present, then we'll use the current date and time. We'll just sample it. So we'll have... So yeah, that means it'll be part of the canonical request. So it means we don't need to pass it in. Right? So let's remove it. It's part of the it's either part of the canonical request, or it will be something that it is generated on the fly. Okay, now what about credential scope? I'm going to have to go back to the documentation to learn what this credential scope means. Yeah, I think it's the date part, and then this part, it's built from 3 different strings, I believe. Credential scope. This value is a string that includes the date, the region you're targeting, the service you're requesting, and a termination string. So the termination string is constant. So let's make 2 arguments, region and service. That makes sense to me. So it would be, well, let's start from the test and go outwards. And I think for all of these, the region's always US East 1, and the service is always named service, right? So we can just hard code these. It's region and service. So we can just hard code them. Static const, not just const. And say it is US East 1. I'm again hoping that all the test cases have that assumption. We'll find out if we're wrong because it'll show up in some test failures, right? So put the region in there, the service in there, and then the canonical request. And now we're working our way outward. So the header should have region and service. And then make the CPP match that. All right, so just sanity check. We'll build and run it again. Okay. Yeah. So no crashes or anything yet. All right, so let's implement it. So standard O string stream, because I feel like using this builder pattern that I've been using so far today, and then we'll just do it step by step. So they say start with the algorithm designation. So let's just hard code it. So output will be AWS 4 HMAC SHA-256. Sounds good to me. And then they want a new line character. We can put that in there actually. And we just chain these. The request date followed by a new line character. Oh, okay. So let's construct that date time. And we'll construct that and put it in there. After that is the credentials. Okay, so credential scope, which is a date, slash region, slash service, slash AWS4 request, new line. Oh, and then we need the hash of the canonical request. So, it's put into hex. So, a couple things for that. Or I already pulled it in. Yeah, so we made this 3 or 4 streams ago. It was a template called string to string. So it's a string input and then a hex string output. And we have to say which hash function. So that's SHA-256. And then we just put in a canonical request. Easy peasy. And this is not followed by a new line character. So just end. Okay, so we need date and date time. So I think what we'll do is we'll scan canonical requests line by line, and we'll look to see if they have, where is it? I should have pinned this. We'll look and see if they have x-amz-date. And then I guess we'll start with we'll start with that as a requirement. And we'll have to add later test cases for this, but we'll also want to support just a plain old date, and if neither one is present, we'll have to generate it on the fly. So yeah, well, right now we'll assume that this has to be one of the headers. So we'll scan for that header. And we'll be constructing the date and the date time. Well, date is simply date time substring. The first, how many characters? 8. The first 8 characters, right? So we just need date time. So for that, we will scan through the canonical request line by line. And did I have a helper for splitting the lines? No, but we can use one that I have in the string extension. So for const line in system abstraction split the canonical request on new line characters. And we'll say if line.substring, how many characters is the x-amz-date? 1, 2, 3, 4, 5, 6, 7, 8. It's 10. Well, let's go to the 11 so we can include the colon, because the colon is the delimiter, right? So then if that's true, then we found the date, and the date time equals line.substring from 12 on, right? And then we can break out of that. So what happens if there is no x-amz date? The date time will be empty, which is fine. We have no test to check for it. One of the rules of TDD is when you write the test which describes the requirement, you only need to write the code to make the test pass. So if we hear reason, we stop and think, well, what if we never get that header? Well, we don't have a test to catch that, so we don't care right now. Later, if we wanted it to work with messages that don't have that header, we'll have to make a test first to say, what do we expect to happen if there's no x-amz-date? Like, let's say there's a date instead. Then we would say, like, well, we expect it to generate the Amazon date from the date, and then we'd have to come back and change the code. Hope that makes sense. So this ought to be complete. Let's see if I get it on the first try, I'll be amazed. Okay, I have a syntax error. Line. Okay, it didn't like something before that. Cannot convert. Okay, so it thinks that this is a string and it needs a character, right? So split wanted a character, not a string. Got it. Okay, compiled in 2 tries. Let's see, will it pass in 1? No. So what did we do wrong? Looks like we chopped the date. We chopped 1 character off the date. Yeah. That's what happened. Oh yeah, this should be 11, right? Not 12. Off by 1 error. Try again. Cool. So only 1 mistake. It's really hard to get stuff like working in 1 try. 2 tries is pretty awesome. 1 try would be like hole in 1 territory. So that's it for make string to sign. Now we're on to the 3rd one. Make authorization. So we'll follow the same loop here, and again, reading from the same test vectors, but here we'll start with the string to sign, and then we'll be generating, what is it? Hold on a sec. Yeah, someone else just came home. All right, so yes, we're going to look. We don't need the canonical request now. Now we're working off of the string to sign can be used to make the authorization, right? So that is our input, and that's our output. Got it? There'll be a quiz after this. All right. Someone was telling me in another stream long, like maybe a month ago, that I sound like their teacher. I'm just trying to live up to that expectation, I guess. Oh, hold on. I'm going to this is already correct, so I'll just have this replace that, and then I'll just paste it again. And we'll make this auth-z. Replace auth-z in all these places. The buffer is auth-z contents. That's auth-z. Okay, so we're expecting the auth z contents to match the return value of, what are we going to call it? Make authorization, just like the test. Make authorization, and then what do we need to pass into it? Well, we definitely need to pass in the string to sign. So that's the string to sign contents. What else? Let's look at the Amazon page. This is now task 3, right? Okay, so we're going to have to calculate, we're going to have to derive a signing key. And then we're going to kind of calculate the signature. Okay. Oh, I guess make authorization might be a mixture of calculating the signature and adding it. Right, because this is what I sort of wanted our code to generate. This entire string. So we'll need to know the algorithm. Actually, that's hard-coded, right? So we'll know the algorithm. We'll we'll calculate the signature. Can we derive the signed headers from the string to sign? I don't remember. Here it is, string to sign. Nope, it's not here. That is in the canonical request down here, though. So how are we going to do this? Nah. We'll have to get it from the canonical request. So we'll have to have the canonical, no, not the string to sign, this canonical request as well. The canonical request, so we'll have to read that in from the file as well. So this takes really two inputs, the canonical request, the string to sign, and generates the authorization value. The string to sign, canonical request, and what else do we need? Okay, the credential scope again. So the scope from before. Oh no, the scope is available in the string to sign. It's in this third line, right? Yeah, so we already have that. And we have the algorithm here too, although we'll know which one it is. So we just we'll need the access key, and I think back in step 3, we'll also need the access secret. No, that's the access key. That's the access key, and what does this need? Access key ID. All right, okay, so let's make that the last parameter. Access key. I believe their test suite has a constant access key. Let's just go back to their document and find out where it is. There we go. Following example, well, it's just that example. Down here in their test suite, let's see what they say. Right, here it is. Here's the key. We need the key and the key ID, actually. Key ID. Actually, they call it the key ID and the key secret, right? Hey, not Zane. In the example, did they use K as prefix for constants? Absolutely maddening. Oh, did they? I don't know. I don't like to use those markers in front much. Key I'll call it the ID and the secret. So there's both, right? What did they do? So that's the secret, I'm guessing, right? So what is the ID? I guess it would be buried in the test vector, right? Because it needed to be part of the auth z. Yeah. This one, AKID example. So that is the ID. Now, did they actually say that and I just missed it? Blah, blah, blah. They probably say it here somewhere. I mean, they show it here. Let me just search for it. AK bling. Sorry for the sounds. They say the scope is that, and then back here on step 3, they said the scope, or was it the 4? That's weird. Here they say it's the access key ID is that part, and then the credential scope is this part. But then down here, they said the whole scope was that. They should have said the scope is that, and the key ID is that, right? I don't know. I'm just going to call the whole thing. No, I'm not going to call the whole thing. I'm going to go by what it says in task 3, and I'm going to say that. No, not 3, 4. In 4, it says key ID and then credential scope, which we can get from the string design. The key ID wasn't in the string design. These parts were. That was in step 2. Right there, they call it the credential scope. Yeah, that's more consistent. 2 places they call that the scope. So the scope is already in the string design. We need the canonical request to get the headers that are signed, and then we need the key, both the key ID and the key secret, right? So that finishes it up. So let's declare that. Oh, I need to go back and document this one too. Let me do that now before I forget. This function constructs the string to sign for an AWS API request in the given region or to a server in the given region for the given service and the given canonical request. How about for the given canonical AWS API request to a server in the given region for the given server? In the given region for the given service. There we go. And first is the region. This is the region string. We'll just say this is the region of the server to which the request will be sent. And then service. This is the name of the service to which the request will be sent. And then canonical request. This is the canonical AWS API request for which to make the string to sign. The string to sign is returned. And let's say this the same kind of thing. The string to sign is as defined by Amazon here. And that's just the general link to the main page, right? Canonical. Oh no, it's not. String to sign. Are you ever planning on profiling your application for performance? I will probably profile it for performance if I see a performance issue. I don't like to do early optimization. Premature optimization, sometimes it's called. So probably when I'm putting it under real load and I see an issue, then I'll start to profile it. That would be interesting to watch. Yeah. I mean, I could make a contrived example where I show profiling. That's a good idea. So let me put that in my notes. Oh, I made a boo-boo here. That's copy from from the last stream. So for this stream, let's say think about making a video about application profiling. Yeah, I think what I would want to do is show how it's done before I actually need to do it, because I don't know when I would need to do it. Yeah, so I usually just wait until it's needed. Should I go ahead and document this thing? Sure. This function constructs the authorization header value. And what is that given? Oh, for the given canonical API request. Using the given access key and string to sign. Okay, the authorization header value is as defined in it's really task 4, but we're also doing task 3. Actually, that had a parentheses in it. This, yeah, we don't need that parentheses. This one also doesn't need a parentheses. Okay. So string to sign is first. This is the string to sign in order to make the signature included in the authorization. And then next is the canonical request, and then next is the key ID, and then the key secret. This is the ID of the key to use to sign the request. And then this is the, what is it, the value of the key? Secret value? Yeah, whatever. And then what is returned? The authorization value is returned. This is added to the original request as a header named authorization. This won't fold for me automatically. Before sending the request to Amazon. Okay, so string to sign. And then it's canonical request, right? And then access key ID and access key secret. Good. And then we'll make a body for this that's empty initially. And it's in a class, so scope it to the class. Return empty. Make sure this builds. And run it. The test will be make authorization. Okay, so the expected values are correct. Okay, good. So time to fill in the code. So let's look and see what we have to do. So yeah, we're gonna, let's work backwards. So we need to make something that says algorithm. Okay, yeah, we're gonna be building something again. O string stream output, return output string, and then it's going to be of the form algorithm. Actually, I'm gonna take that algorithm and just make it a constant. Hash algorithm. So we'll make a constant up here. Static const char star const equals. Oh, it's that is the name. Hash algorithm. Well, this is the identifier defined by Amazon. For the hash algorithm, use to make message digests in this module. Yeah, so right now it's just hard-coded to SHA-256. That's fine. So hash algorithm, what next? A space and then credential equals. Well, okay, space, credential equals, and then they want the access key ID. And then they wanted a slash, right? And then credential scope. So we need to derive that credential scope. And then let's the next line say comma signed headers equals, and then we need to another thing to derive, right? Signed headers. And then another comma signature equals, and then the signature. And that's it, right? Yeah. Easy peasy, right? So now we're just missing three things. Credential scope. That was where? Where is the credential scope? That's here, right? The third line of the string to sign. So again, we'll split it and we'll take the third line, right? Split it. So const auto credential scope equals, so we can just split it and take the third one, counting from 0. Right? And then signed headers. Signed headers is a little bit more difficult because we have to go back to the canonical request, and we basically want the next to last line. So if we have canonical request lines is, oh, this is the wrong thing too. That was the string to sign. This is the canonical request lines. If those are the lines, then the signed headers is the canonical request lines. Canonical request lines length, really it's a vector, right? So size minus, that's -1 and that's -2, right? Okay, signature. Here's the hardest one to make, right? Calculating the signature. So first, derive the signing key. To do this, use the access key to create a series of HMACs. Okay. Okay, so we need the date. So yeah, we need to extract the date. The date was where? The first part of the credential scope. So if I split the credential scope, if we split it on a slash, it would be the very first one, right? And then we have case secret. Look, yeah, we start with that. Then we have well, we need to get the region and the service. Those are also in that line, right? Oh yeah, that's region and service. There we go. So let's split this first into parts. And then the date is the first one. Region is the second, and the service is the third. Okay, so then, yeah, then that means the signing key equals, and then here we need to include HMAC. HMAC? Is that it? I think so. We're going to be calling HMAC string to string to bytes. One of these guys. What do we actually need the key? What format do we need the key in? Okay, so it should be a hex. Right, so it's going to be hash HMAC, make HMAC string to string. And then it's a series. It's, oh, all right. It's that, I'll just take that. We're going to be chaining these. Wonderful. 1, 2, 3, 4. Wonderful. I like it. Okay, and then the innermost is AWS4 concatenated with access key secret. When do we need the access key ID? Oh, we needed it down here. Okay, that's the first part of it, and the second part is the date. And then the second part on next of the outer is the region. And then the second part of the next level is the service. And then the last part of this one is AWS4 request. Oh, that was oh, it's hard coded. But it also happens to be in that credential scope. Maybe we should pick it out of the credential scope. So that would be what do they call that? Termination string? Okay. Yeah, it's the same string. I'm going to assume that it has the same meaning, so termination string. We'll just pull it out, then we don't have to hard code it in more than one place, right? Termination string. Okay, I messed something up. Oh, this is making a function. Yeah, okay, we need to make the HMAC function first. So HMAC equals make one given the hash function. Yes, so that the hash function is hash SHA-256. And then we call it in all these places, right? I know I messed that one up. Did we not include SHA? I did include SHA-2. It's hash SHA-256, right? Oh, there's a block size. Okay, fair enough. What was that block size? It was like SHA-250. I can't remember. SHA-256 block size. Yes. Now you should be okay, right? Still no? What's the error? Cannot convert from Oh, right. It needs this string to string needs this string to string version of the hash function. That's hash string to string of that hash function. And then how come it doesn't like this? It's undefined. Oh, that's because it's in a namespace. Cool. So could I collapse these and make it still readable? Kind of getting long. I don't like that. I'd rather do it like this, even though it's sort of funny. Okay, anyway, that just gets us the signing key. Then after the signing key, what do we do? What do we do with the signing key? Calculate the signature. So it's just HMAC again. All right. So const auto signature equals HMAC signing key with the string to sign. There we go. Will it compile? No. Missing something on 204. Yes. Well, hold on. Yeah, since that's not a macro, I can't just glue those two together. Why isn't it like this? I think that's just a build thing. Yeah, it was just a stale error message. Let's see if I got it on the first try. Of course I didn't. Yeah, the digest is completely wrong. Well, it's very rare to get it correct on the first try. So we'll need to step through a specific example to see what I did wrong. I mean, yeah, it's correct all the way to the digest, isn't it? Well, that's good. Yeah, we just got the digest wrong, so to figure out what's. So they walked us through the example, right? Yeah, so we can see if we get the correct signing key if we use that. Is that the key that they use for the test suite? I don't know. Let's look. Actually, it is. Only this says IAM, not service. They used service, right? In their test suite. Yeah, they have service. Okay, we'll have to add an exact test case for this, so let's do that. Make authorization test case from documentation. So it's literal. We'll just put it in literally. We can put this part in. Actually, no. Let's just glue them in exactly. And then the string to sign they gave us. Right? Where'd they give it to us? Oh, that was just the signing key. So let's see. Does that example match 5D? Is that what they gave us here? 5D. Okay, so yeah, they're chained together. Right, so was this the string to sign then? Yes. This is the string to sign. We have to be careful though. It's a multi-line thing, so It's exactly that, and then I can take advantage of the fact that this will get glued together if I just chain them end to end like this. And this does not have one at the end. So there's the string to sign, and what's the canonical request for that? They gave us that too, right? Step 1, they gave us that. This thing. All right, so it's get new line slash new line. That new line, right? Yep. I'll verify this before I run it. And then just an empty line, and then that, and then this with no new line at the end. Okay, and then the authorization. What do we expect? This exact string, right? That exact thing. Okay, let's verify. So what was the original request? This. Okay, so it had a query string, which is there. Content type host and the date. Okay, yeah, let's just try this out. Then we can, if it doesn't work, we can step by step go through and find out why. Oh, yeah. Don't need that part. Okay, that was from doc something. Right, so this isn't matching this, and it's because of this signature is not the same. But everything else looks like it's the same, right? So let's step through it. We'll go here, and let's just say go. I have this set up to debug already. And then we'll go into the make authorization, put a breakpoint there, and hit go. All right, so credential scope is that. Looks correct. Date is that. Region is that. Service is IAM. Termination string, that. HMAC, we made the function. So the signing key, did we get the correct signing key? 8C02, let's look. No. So we already failed on the first step. Fail. So we should probably verify from the inside out, I guess. So restart. Restart, I mean. And then go to here, and what'll step in do? Yeah, it's not really working. Stepping in didn't really work. Yeah. I'll have to find the lambda expression that goes with this. So that is here. Yeah, let's put one here too in the inner hash. Okay, so go. Okay, so the key is, yeah, that's the, oh, wait a minute. This doesn't look right. It should have been the innermost one. AWS 4 plus key secret. Okay, it is. AWS 4 and then glued with 4WJ, and is that the key? Wait a minute, I was reading that wrong. AWS 4 and then capital JA. W capital JA, yeah. And it ends with key. Okay, and then we're hashing it on the message 201508030. Right, raw string to bytes like it should be, I think. Oh, wait a minute. This might be the issue. This might need to be hex string to bytes, right? No. The key right now... I see. I think I know what the issue is. Yes. At each step, it's supposed to be a raw string, right? But each HMAC is returning a hex string. So yeah, it's not, it's going to misinterpret the hex string as a raw string for the next HMAC. So, hold on. All right. Yeah, so two choices, I guess. I could either do it string to bytes. No, bytes. I could do bytes to bytes and then convert it to a... I can make the last one HMAC to string. Yeah, we'll just use all three because we have to... The first one has to be a string to bytes, and then all the other ones have to... All the middle ones are bytes to bytes, and the last one is bytes to string. So this is string to bytes. And then the last one will be bytes to bytes. Byte, yeah. String to bytes, and then finally bytes to string, and in the middle, it's bytes to bytes. Like that, right? Oh, that, and then that. We actually don't need a bytes to bytes, it's just the raw hash function at that point. There's no bytes to string. Did I not make one? Oh, it has to have the word function at the end. Okay, so the innermost is, because the inputs are raw strings, it's bytes to strings, and then the intermediate ones are bytes to bytes. Okay, but this has to be converted to bytes. Okay, we can do that. So we can just say, that's just vector 8t service begin, service end. And then again at this step, and the same thing here with region. And then the outermost one will be bytes to string. Yeah, and again, the termination string has to be converted into bytes as well. And then that final one, oh, wait a minute, the signing key, we wanted bytes as well. Yeah, let's make it bytes. And then, so this one will be bytes to bytes. And we'll just have to, we'll use the signing key, but then the string to sign has to be converted into bytes. So everything is being converted into bytes, really. Which is fine. Oh, no, hold on. I wanted the signature to be a string. Hex string. Yes. Yes, the final signature is a string. So, let me go over this again. We make 3 HMAC functions. One that takes raw string, converts it to bytes. Middle ones are just bytes to bytes. The final one is bytes to a hex string. Maybe we should be explicit about this. Hex, and this is raw. So, the signing keys, first we take the raw string, these two raw strings, and then we HMAC it into bytes. And then we do the HMAC three more times, really. And then we end up with a raw byte signing key. And then finally, we do a bytes to hex string, HMACing the signing key with the string to sign, and we get that back as a hex string. Okay, that sounds good to me. Will it work? Hello, in vain. I am back. Keep forgetting where I'm looking at the screen, and really, you're up there. Hi. Let's see if this works now. Yeah, in vain, you're just in time to see my signing work. Let's go back to the authorization and see how many of those pass. They all pass. Great. So the only things we need to really take care of are fixing these two test cases that Amazon got wrong. So, do we check in? Let's check in. AWS, let's check this stuff in. This is a typo. So, fix documentation typo. Okay, now what was this? Yeah, we made the string to sign and authorization functions. Right. So AWS, or sign AWS, sign API. Add these two methods. Make sign string to sign and make authorization functions. Or functions. Okay, cool. Did I make any other changes? That's the question. I think I did. I deleted what I considered was an invalid test vector from Amazon. Right? Maybe I gave him feedback and I told him to look at my Git repo. I don't know if they ever will. Probably not. But I consider this test invalid because this form of wrapping, like having a line that begins with a space, mean that you're concatenating values together to form one composite value in a header. I consider theirs invalid because what they decided to do was put commas. I looked it up in the RFC for HTTP 1.1, and they're supposed to be spaces, not commas. So, I mean, I could correct it by making these spaces, but I decided to remove this entirely because the spec for HTTP 1.1 also says that you must not ever create a request that does this what they call obsolete folding. So I'm like, if we're not even supposed to make something that looks like that, why the heck are we worried about signing such things? So I'm deleting that. So remove I'm declaring it invalid. Remove invalid test case get header value multi-line. And I'm going to say why. So this test case is invalid because RFC 7230 section, what did I say it was? 3.204 states that a sender must not, and I'll copy this verbatim, this part at least, generate message that includes line folding. Since also the same RFC says a server receiving such a message may, I don't remember, may accept it by replacing obsfold with space. However, this test case from Amazon assumes instead that OBS fold should be replaced by comma. Hey, playing with scissors? Please, no more AWS. Are you guys tired of it? I didn't have a chance to watch Adam's stream today, but I know he's buried in the Docker, was it Verdaccio? Did I say that right? And other things relating to AWS. I'm actually almost done with this, so you only have a little bit more to endure. I'm just making my own library to sign API requests from them. This case is invalid because of that. Also, the same RFC. Okay, yeah. I'm justifying why I think Amazon was stupid in making this test case. So if they ever look at my GitHub, they'll read my justification. Maybe I'm wrong. Maybe they'll school me. I don't know. So they have two other test cases which I consider invalid. Let's go fix those. And we'll fix them by assuming now that our tests are correct, or that our code is correct. So I will fix the test vectors just by changing what the input is and then see what the output is, and then making that the expected value. So the buggy tests are down here. So any HTTP 1.1 Pro knows that if you have a body to a message, you must have either content length or transfer encoding. Right? Did I get that right? I don't claim to be an expert. I have to have a notebook to back me up. Where did I say this? A couple streams back. Right. Transfer encoding. Says so in the RFC. I trust the RFC more than I trust Amazon. So they're not valid because they're missing those. So let's just set the content length. So it would be an extra header right here. Content length of, well, however long this is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is Adam stream all over again. Well, please tell me that Adam was successful today. I'll watch the VOD later. How many hours did he go? Like, he did a half day, so 4 hours. So I need to correct, I'm gonna have to correct the canonical request because we've just added a header. So we have to add it in the correct place. It would go first because we're sorting it. It would go there, right? And then we'd have to include it here. And now all these other codes are going to not match, but running our code will tell us what they should be. So let's do the same thing here. This is, again, a content length 13. This is the same string, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And we need to put the canonical header here, content length 13, and then we list it here, content length. All right, so now we'll run the unit tests, find out what those values should be. Right, so here's what they really are. Here's what Amazon said it should be, but they're bullshit. So we're going to replace that. Excuse me. 2E1CF. Oh, hold on. I'm not starting from the top, am I? Starting from the top. Oh, hold on. Oh, yeah. Okay, my editor goofed. I need to turn off the editor config. It's adding the new line. We don't want it to. So go to editor config. Temporarily turn that off. Go back and remove these. All the places. They're not supposed to end with a new line. Okay, and then I'll leave the editor config off for now. Yeah, so let's try that again. Okay. Yeah, so now they only differ in the digest. So this is what the digest needs to be in the canonical request. And this one's matching the one that says parameters. Oh, wait a minute. It's running my test in a different order. I want to do the canonical request one first. Let's just run that by itself. I didn't expect it to pass. Why is it passing? Is it passing because they screwed up? Okay. If it's passing now, that means... Okay, this will be funny, but this is what I changed. What did I change? How come it's not showing the diff very nicely? Okay, yeah, I added content length 13. to the original request and the canonical request, but I didn't change the digest or the signing. Oh no, those don't affect the message digest. Yeah, what am I thinking? I'm just being dumb. I'm dumb a lot. Yeah, those. What am I doing? I need to go back to my build directory. The canonical request will pass now because that's all I really needed to do. It's the string to sign is wrong because that has a digest which of something which I did change. So here's the new digest, and this is for the parameters one. And that's in the string to sign. So here's what the digest is now. And then the same thing for the other test. So 42 replaced by A1. Right there. Boom. Okay. So we'll run the test again, because one depends on the other. Okay, so now the signature changes. It all ripples down. This is why the signing works. If you change anything in the message, all I did was add content length, and it changes the digest in the string to sign, and it changes the signature. So here's the real signature. So 1A72. This guy changes to that without the double quote at the end. And then the other one is this signature. Goes here. There. Oops. What did I do? Did I not say that? What did I do wrong? Did I get them backwards? Oh no, something else changed. Oh yeah, the content type was, content length is added in there. That is in signed headers. Content length, semicolon, on both of them. All right. There we go. So there we go, playing with scissors. I'm done with AWS. Happy now? Oh, let's go check that in. We're done for now. I am not talking to the real AWS. I'm only using their test suite, and and this sucks that I have to do this, but I had to fix their test suite by adding in content length because it was missing, which changed a bunch of digests. I told them about it. I don't know if they'll listen, but fix two test cases that fix two broken test cases, and we'll say why in the body here. Whoa. I hit the wrong button. We'll amend. Now these test cases have message bodies. HTTP 1.1 request messages must have either content length or transfer coding or encoding. Headers if they have bodies. These test cases are missing both headers. Fix the test cases by adding the content length header. Now this changes the string to sign digest as well as the signature. I mean, we could avoid changing the string to sign digest to the signature by not listing content length as a signed header, but then that complicates my code because my code I have to have some way of saying don't include content length when you sign, and right now it signs using all the headers because it's like, why not? Okay, push that. Let the bodies hit the post. Thanks for following Pink M&M. You can make a pink M&M, by the way. Take a red M&M and put it in underwater for a little bit, right? Okay. I hopefully did not have to change my code. It was just a test case issue. Oh, what did I change at the root? Oh, I changed the editor. I can change that back now. I can change it back by doing reset hard. Ha ha! Take that, editor config. Okay, we're in good shape. Let's run all the tests. This always gives me the warm fuzzies when all my tests pass. PogChamp, all tests passing. So today's objective met. We have done everything. We have done all the things. Does that mean I'm done? I guess I'm done for a while. We could put this into practice. I have to actually learn about an actual Amazon Web Services API and try to make a request to it. So I'll need to do some research on that. Yeah, actually, might be done. Been going for an hour and a half. I was going an hour and 50 minutes before, so it adds up to a decent amount of time for the day. So probably next time. Actually, I'm not sure. I'll either be trying to put this API library I made into practice with Amazon for real, or I'll be going back to do some web server stuff, or I'll be starting on my game. So I've been thinking about making a multiplayer game using Amazon Web Services to make it persistent and using my web server as a base for the clients talking to the server. So it'd be basically all WebSocket calls to the server, which will be based on my web server. So might be working on that. Not sure, but I'll have to think about it. But guess we'll wrap things up for now because I'm out of things to do. We'll see see if Ski Dog is going today or someone else. Let's see. I'm just gonna peek and see who's streaming right now. Oh. I thought Ski Dog was gonna stream on Wednesday. Is he not going again until Thursday? That's probably I don't keep track of other streamers as much as I should. Too early, huh? I think he's also skips Wednesday, right? Okay, so I could introduce you to an Irish game dev, or we can go just host Heartbound, or do something completely different. I haven't seen what this guy's been doing lately, so let me just peek it, and then I'll post a link to it, and we'll just do it. We'll just set up a host. How about that? So his name is Irish John Gaming. There's his link. Looks like he's been working on this multiplayer pirate ship game. He says he's refactoring his AI state machine, so we'll go check that out. So yeah, thanks guys, and I'll see you hopefully tomorrow. But if not tomorrow, then soon. And until then, take care. I'll go host Irish John Gaming. See ya.